यस है हम ये है गुरुकुल हमारा।
Hello students, I am Priyanjali Mukherjee, Assistant Professor of Electrical Engineering Department of Narula Institute of Technology. In this video, we will discuss on the two-port networks, reciprocity and the symmetry condition. In this video, we will cover the transmission line parameter, the hybrid parameter, the reciprocity and symmetry, different conditions of reciprocity and symmetry with examples. So first start with the transmission parameter. This representation is widely used in the power transmission and it is also called as the transmission parameter or the circuit parameters. Now this is also represented by ABCD parameter, which represent the relation between the input quantities and the output quantities in the two-port network. They are voltage and current pairs. However, as the quantities are defined as an input-output relation, the output current is marked as going out rather than incoming to the port. So we use the reverse direction of the output current and hence it is given as minus. So we can write down in this way that the V1, I1, those are the input voltage and input current, and that is equal to ABCD, this is the parameters, into V1 into minus I2. From this matrix equation, we can write V1 equal to AV2 minus BI2, whereas the I1 equal to CV2 minus DI2. Now we can consider two cases. For the case 1, we are considering that the output port is open circuited. So when the output port is open circuited, then this I2 current goes to 0. So at the condition I2 is equal to 0, we can say that A is the ratio of V1 by V2 and it is known as the open circuit reverse voltage gain. Whereas if we put I2 is equal to 0, then we can find out C equal to I1 by V2 and this is known as the transfer admittance. And for the next case, we are considering that the output port is short circuited, and when the output port is short circuited, then V2 will go to 0, and at that condition when V2 is equal to 0, we can say B is the ratio of the V1 and I2 and it is known as the transfer impedance, whereas B is the ratio of I1 and I2 and it is known as the reverse current ratio. Now these parameters are known as the transmission parameter, as in transmission line the currents enter at one end and leaves at the other end, and we need to know a relation between the sending end quantities and the receiving end quantities. Next is the hybrid parameter. The hybrid parameter represents a mixed or the hybrid relation between the voltage and the currents in the two-port network. And this representation is widely used in case of transistors. Both open circuit and short circuit terminal conditions are utilized here. And here the voltage of input port and current of output port is expressed in the terms of current of input port and voltage of output port. So here this is the equivalent circuit of the hybrid parameter. the input voltage and currents are V1 and I1, whereas the output voltage and current is V2 and I2. So we can write the equation, the V1 and I2, that is equal to H11, 12, H21, H22 into I1 into I1 V2. So from this matrix form, we can rewrite the equation like this: V1 equal to H11 I1 plus H12 V2, and I2 equal to H21 I1 plus H22 V2. Now we can consider two cases. So for the case 1, we are considering that the output port is short circuited, and at that condition V2 becomes 0. So when we put the V2 becomes 0 in the equation 3 and 4, we can find out that H11 is the ratio of V1 and I1 at the condition V2 equal to 0, and it is known as the input impedance. Whereas from the second one, we can find out that H21, that is the ratio of I2 by I1 at the condition V2 equal to 0, and this is the forward current gain. And for the second case, we are considering that the input port is open circuited, and when the input port is open circuited, then the I1 current is 0. And at this condition, when I1 current is 0, then we can find out from the equation 3 and 4 that H12 equal to V1 by V2 at the condition I1 equal to 0, and it is known as the reverse voltage gain. Whereas the H22 is the ratio of I2 by V2 at the condition I1 equal to 0, and this is known as the output admittance. So from this equivalent circuit, we can say that this H1 into V2, this is a voltage source, but it is dependent voltage source which depends on the secondary voltage V2. Whereas H21 into I1, this is the current source, and it is a dependent current source which depends on the input current I1. Next, consider the reciprocity and the symmetry. Now, a network is said to be reciprocal if the ratio of the response transform to the excitation transform is invariant to an interchanging of the positions of excitation and response of the network. Now, a two-port network will be reciprocal if we interchange an ideal voltage source at one port with an ideal current source at the other port, then does not alter the ammeter reading. If it is possible, then this two-port network is said to be reciprocal, and it is said to be symmetrical if the input and output ports can be interchanged without altering the port voltage and the current. So let us find out the condition for the reciprocity and symmetry in terms of Z parameter. So for this one, we are considering that voltage V is applied at the input terminal and the output is short circuited. And we are also assuming that the I2 is in negative direction. Now, as the output terminal is short circuited, so V2 becomes 0, and the governing equation of the Z parameter becomes V1 equal to I1 Z11 minus Z12 into I2, and the second equation becomes 0 equal to I1 into Z21 minus Z22 into I2. So, from these two equations, we can find out that this I1 is equal to the I2 into Z22 by Z11. Now, we can substitute this value into this equation 5. So, we can find out the value of I2, that is V1 into Z21 by delta Z, where delta Z is expressed as Z11 into Z22 minus Z21 into Z12. Now, we are interchanging the excitation in response. That means the voltage is applied now at the output terminal, and input is the short circuited condition. Now, at that condition, the V1 becomes 0, and the V2 equal to minus I1 into Z21 plus I2 into Z22, and 0 equal to Z11 into minus of I1 plus I2 into Z12. So from this equation we can find out that I2 equal to Z11 into I1 by Z12. Now we can substitute this I2 value into this equation. That means V2 equal to Z21 into minus of I1 plus Z22 into I2. After substituting that value, we can find out that I1 becomes V2 Z12 by delta Z. Now the condition for reciprocity is I1 should be equal to I2, because if we interchange the ideal voltage source at one port with an ideal current source at the other port, does not alter the ammeter reading. So I1 and I2 should be same, and the condition for I1 and I2 becomes same, that is Z12 is equal to Z21. So for the reciprocity, the condition of for Z parameter is Z12 equal to Z21. Next we need to find out the condition for symmetry, and for the condition for symmetry we are assuming that the voltage is applied at the input port keeping the output port open, and in that case when the output port is open the output current I2 is 0. So the Z11 becomes V1 by I1 at the I2 equal to 0, and again we are applying voltage, same voltage V at the output by keeping the input port open, and at that condition the Z22 becomes V by I2 where the I2 is equal to 0. Now for the condition of symmetry, it will be observed when V by I1 equal to V by I2, and from this equation we can say that the condition for symmetry is Z11 equal to Z22. So if this Z11 equal to Z22, then the Z parameter is symmetrical, and if Z12 equal to Z21, then this Z parameter is reciprocal. Next is the condition in terms of Y parameter, and here we are considering that output terminal is short circuited, and the governing equation is of the Y parameter is I1 equal to V1 Y11 plus V2 into Y12, and the second equation becomes I2 equal to V1 Y21 plus V2 into Y22. Now as the output port is short circuited, so V2 is equal to 0. So from this equation we can say that Y21 equal to minus of I2 divided by V1. Now we can interchange the response and excitation by shorting the input terminals. So V1 becomes 0 and Y2 equal to minus of I1 by V2. So the circuit will be reciprocal if this condition Y of 1, 2 is equal to Y of 2, 1. And for the symmetry, it will be symmetric if the input and output port can be interchanged without changing voltage and current. So output is keeping short. So when the output is in short circuit condition, then we can write the equation that is equal to output is short. That means when output will be short, the voltage of V2 becomes 0. So we can write Y11 is the ratio of minus of I1 and V1. Whereas when the input is short circuited, then we can find out that Y22 is equal to minus I2 by V2. And for symmetrical, the Y11 must be equal to Y22. So here also the condition for symmetry is Y11 equal to Y22, and for the reciprocity, that is Y12 is equal to Y21. So these are the different parameters, the condition for reciprocity and condition for symmetry. So for the Z parameter, we can say the condition of reciprocity is Z12 equal to Z21, which is similar in the Y parameter, that is Y12 equal to Y21. And for the symmetry, Z11 equal to Z22, that is also same, as the y parameter, that is y11 equal to y22. Now for the transmission parameter or the ABCD parameter, the condition for reciprocity is AD minus BC equal to 1 and the symmetry is A equal to D. Whereas for the hybrid parameter, the condition for reciprocity is H12 is equal to minus of H21, and for the symmetry we can write H11 into H22 minus H12 into H21, that is equal to 1. So these are the different conditions of reciprocity and symmetry for the different parameters. These are my references. Thank you. Hope after this video lecture you have a clear idea about today's topic. Now we will go through some questions and answer session in the context of this video lecture. Now you are requested to go through gradually and try to solve the MCQ questions by your own. Answers are also attached at the end of each question.